Welcome to this presentation on evolution of artificial intelligence. AI has come a long way from simple rule-based systems to powerful tools that can create content, mimic human creativity, and handle complex tasks. This progress didn't happen overnight. It was built step by step through revolutions in how machines perceive, learn, and generate. In this journey, we'll explore four major areas of AI: symbolic AI, statistical AI, deep learning, and the exciting new frontier of generative AI. Each stage pushed the boundaries of what machines can do, and by understanding this evolution, we'll be better prepared for the present and the future. Whether you're a developer, a researcher, or a decision maker, this knowledge gives you the context you need to make smarter choices with AI. So let us begin with a quick overview of these four transformative stages. Artificial intelligence didn't appear overnight. It's the result of decades of progress in both ideas and technology. In this presentation, we'll look at AI's journey through four big eras, each one reshaping what machines can do. First came symbolic AI, where rules and logic were written directly into machines. Then statistical AI, using data and probability to make smarter predictions. Next, deep learning, where machines began uncovering complex patterns from massive amounts of raw data. And today, we are in the era of generative AI, where machines are not only analytical but creative. Understanding this journey is not just theory. It helps professionals choose the right tools and models for the real challenges they face in their fields. So let us dive in, starting with the foundation, symbolic AI. Let us start our journey in the 1950s with the symbolic AI, the rule-based era. Back then, the belief was that intelligence could be built by manually encoding knowledge into machines. Programmers wrote logic step by step. If this happens, then do that. This approach was deeply inspired by formal logic and mathematics. Symbolic AI led to some of the earliest breakthroughs. For example, mycin, an expert system for treating infections, could even outperform junior doctors in certain cases. Early chess programs also used handcrafted rules and decision trees to make their moves. These systems were clear and transparent, and they work well in very specific tasks. But they were also brittle. A small change in input could break the whole system, and updating them meant rewriting massive set of rules. Because of these limits, researchers began searching for more flexible and data-driven approaches. That shift brought us into the next era of AI, that is statistical AI. The 1980s brought a major shift in the AI, from symbolic reasoning to statistical learning. Instead of programming every rule by hand, engineers began building models that could learn patterns from data using probability and statistics. This era gave us practical systems like spam filters powered by nav bias and early speech recognition models using hidden macro models. These approaches made AI more adaptable to real-world situations, even when the data was noisy, inconsistent, or incomplete. But challenges remained. Models required a lot of manual effort to engineer the right features, and the classic phrase applied: garbage in, garbage out. The quality of the results was tightly bound to the quality of the data. Still, this era built the foundation for next revolution in AI, that is deep learning. The 2010s marked the rise of deep learning, a turning point in AI powered by stronger computers and smarter neural network designs. Unlike earlier methods, deep learning models could automatically extract useful features straight from raw data. No heavy manual pre-processing is needed. So this era brought huge breakthroughs. Neural networks dominating image recognition, recurrent and transformer models driving advances in language translation, and deep architectures revolutionizing speech recognition. These systems proved that with enough data and compute, AI could reach and sometimes even suppress human level performance in specific tasks. But these were trade-offs. Deep learning demanded massive datasets, enormous computing power, and the models often work like black boxes, difficult to explain and harder to fully trust. Still, this era set the stage for the next big leap in AI, that is generative intelligence. We have now reached the current frontier of AI, the era of generative models. Unlike earlier systems that only analyzed or classified data, generative AI can create new content. From human-like conversions to stunning digital art, these models extend and even mimic human creativity. This revolution is powered by transformer architectures and large-scale training. Tools like ChatGPT and GitHub Copilot are everywhere, helping people write, design, and code. They are not just boosting personal productivity, they are transforming entire industries. But with this power come new challenges. Generative AI can produce misleading content, amplify biases, and raise typical ethical and legal questions. That's why adoption must go hand in hand with responsibility, transparency, and thoughtful design. Understanding the evolution of AI is not just theory, it is highly relevant for today's professionals. Each era of AI brought new strengths and new limits. By learning from them, we can choose the right tools and avoid repeating past mistakes. For example, Symbolic AI taught us transparency, Statistical AI introduced adaptability, Deep Learning gave us perceptual intelligence, and Generative AI unlocked creative synthesis. These approaches are not interchangeable. Each has its strength and weakness, depending on the problem you are solving. As generative tools become more common, it is important to use them statistically, not just reactively. Whether you work in business, healthcare, law, or creative arts. Your understanding of AI journey will shape how well you can lead, innovate, and adapt. To wrap up this journey, we have seen how AI has grown from handcrafted rules to probabilistic models to powerful neural networks that can both perceive and now create. Each era expanded what machines could do, and each brought new opportunities along with new challenges. Today's AI is at a convergence point. It's not only generating text and images, but also being woven into fields like bioengineering, healthcare, and education. But with this power comes responsibility. The more capable our systems become, the more important it is to design them with ethics, accountability, and purpose. As professionals, we are not just users of AI, we are stewards of where it goes next. By understanding the past, we are better prepared to shape a future that is innovative, inclusive, and intelligent by design.